Good morning, everyone. A warm welcome to the FDP 5-day FDP program on a focus on surging tech savviness, research skills, and work-life balance for modern educators. Session 5. I welcome our distinguished principal sir into the session. Sir, good morning, sir.
Good morning, Amma. Is it audible?
Yes.
Yeah, thank you. Respected today's the chief speaker, Dr. Manju Rawat Singh, Madam. Good morning. I welcome Madam, first of all. Introduce. Madam, good morning and welcome to this session of the
Good morning,
this
sir. Good
FDP.
morning.
Good morning, Madam. Dear respected today's chief guest, Madam Dr. Manju Rawat Singh, colleagues, delegates, and dear students, good morning to all of you and welcome this 5 days online faculty development program. Today, we have a wonderful a speaker, very young and having the very best track record in the research and publications and the patents, whatnot, postdoc in USA, and all together a great speaker is with us. And definitely today's deliberations, a memorable deliberations for every delegate. And definitely you will have very good interaction, and this interaction for everyone is possible that you have to utilize this as the best opportunity for all of you. And now I request to get the board into the Madam Lakshmi Usha to introduce the our speaker before the program.
A very good morning to one and all. Myself, Lakshmi Usha, Associate Professor, Raghu College of Pharmacy, is glad to introduce our today's speaker, Ms. Dr. Manju Rawat Singh. Manju Rawat Singh completed her post-graduation in pharmaceutical biotechnology from Dr. H.S. Gaur University, Sagar in 2004 and PhD from University Institute of Pharmacy from Pandit Ravishankar Shukla University, Raipur, where she is currently working as associate professor. She did her postdoctoral research from University of Mississippi, Oxford, USA. She has around 19 years of teaching and research experience. Her prime areas of research include designing strategies from protein and peptide delivery, topical systems for autoimmune disorders like psoriasis, rheumatoid arthritis, and inflammatory bowel diseases, and experimental designing using advanced statistical and mathematical modeling methods. She has more than 100 research publications in various national and international journals and several book chapters. Her Google Scholar citations, she has around 6,227 Google Scholar citations with an H indexing of 35 and I indexing of 89. Her corpus H indexing is 26. She also have 2 international and 3 Indian patents. 2 of her books were published with Elsevier and 2 more are in press with CRC. She is one of the top 2% scientists worldwide in the field of pharmacy and pharmacology listed by Stanford University for the last 3 consecutive years. She has successfully completed several projects funded by ICMR, UGC, Chhattisgarh State Council of Science and Technology, and Department of Science and Technology. She is a recipient of DHR ICMR International Fellowship for the year 2014-15 and also a number of awards at national and state level for excellence in research, including Young Scientist Award of the State of Chhattisgarh in biotechnology. She has been bestowed with the Best Teacher Award at Ravishankar Shukla University in the Department of Science. She is the national convener of IPGF Women Forum, life member of various professional bodies, President IPGA Chhattisgarh State Branch, Joint Secretary IPA Chhattisgarh State Branch, and was the co-convener of APTI Women Forum. She was the visiting scientist at School of Pharmacy, Department of Pharmaceutics, University of Mississippi, Oxford, USA, and is engaged in research projects focused on studying pathophysiology and devising new treatments, mainly autoimmune and inflammatory diseases, in collaboration with various international and national universities. Welcome, ma'am.
Thank you so much. Thank you, Dr. Pandaji, for your kind words and such a warm, welcome and this introduction. So, can I start with the presentation now?
Yes, ma'am, you can proceed.
So, first of all, I would like to really, I would like to say thanks to the entire team of Raghu College of Pharmacy for organizing such a wonderful, event, which is on the topic which is really needed and so timely. Whether you talk of artificial intelligence, whether you talk of patenting, which is really, nowadays, these are the two main areas where everyone is focusing. And I must congratulate the entire team for selecting such a wonderful topic. The topic that I'll be covering up today will be on implementation of science to practice using research methodology in pharmacy. And specifically, I'll be emphasizing on DOE approach, that is design of experiment approach. When I say that, when we talk about pharmacy is basically it's a technical subject basically, and wherever the technology comes, wherever this technical term comes, it is associated with the implementation of science, and science can never be implemented well if it is without the experiments. So the first and foremost thing in this case is the experiments. So what are actually these experiments? So we perform these experiments in our lab, in our day-to-day lives. So basically, these are systematic procedures that we carry out under the controlled conditions. I'm saying controlled conditions where we actually look for the various variables, various factors that we can control, which we can actually control. And this is to discover an unknown effect based on the hypothesis, or to whether to test it or establish that hypothesis, and finally to demonstrate the desired outcome that we want out of it. So for any experiment, I think two things are very important. The first is the input, that is what all factors we are keeping up, and that could have an impact on the process output. And another one is the output, which is actually what is our the major outcome that we desire out of our experiment. That is the target level of those inputs, which should be to achieve a desired result. So these are the two major components whenever we think of the experiments. So this, I think all of you who are indulged into some or other kind of research must have undergone these two kind of dilemmas. Whenever we do any kind of experiment, whenever we want to test any hypothesis, we can we come out with two kind of results. One, you can see is a scientist with a happy face at the down, and the one with a sad face. So happy when he's having the results which he actually which are desirable to him, and which are actually well expected, and unhappy when the results are not as expected by the scientist. So obviously, when we think of experimentation, we want to be the second scientist, not this former one which is unhappy. We want to be the happy one with the desired results in our hand. So these are the three kinds of phases of experimenter, depending on the kind of the control of experiment that he or she want to perform. So the first phase says that I have tried every kind of combination, the problem and the treatment, but I'm not having any desired result in my hand. So it is actually the unhappy kind. So this person is roaming around the bush, nowhere near the main result. The second kind of experimenter is the one who says that I have tried one treatment, and I think it should be the best. I'm not going to try any other experiment, any other combination, and whatever I have selected, this is the best. So in a way, we can say that he's a confused personality, because he's not still sure that whatever he is going to get out of that result is correct or not. The third one who will use actually, who want to use the statistical designing and DOE to get the minimum cost and reproducible results. And he actually is the one, if you can see this, the picture there, you can see the knowledge space, the design space, the control space. So this is actually the area where he want to, based on this, he will work on the knowledge space, he will reach the design space, and finally his result will be obtained in the control space, which is the optimum result that he's going to get out of it. And I'm going to compare it with, like, for example, if you consider there is a mason or an architect and you want to build a house for you, and you just say to that mason and the architect that just make a house for me, but you have not told him about the land, the area where he'll be building the house. So in that case, we are nowhere actually near the knowledge space. Second is the one where we give the entire authority to the architect and we say that, okay, this is the area, but it is actually 2000 square feet or a 5000 square feet area, and you build a house for me. So that architect is not aware what is actually your main requirement, what kind of house do you want. He will make the any one of his like choice, and he thinks that the whatever he has made is the best for you, no matter whether you like it or not. So this is the case of a second kind of experimenter. The third one, when you will give the architect the entire the area, the space location, the kind of the rooms, the number of rooms, the kind of requirement that you have, and based on your requirement, then the architect makes the house for you. So this is actually basically comes under the design of experimentation approach. So this example I've just quoted to make you more aware that how actually our experiment should be designed. So if we talk about the previous one, the former one, experimenter, it would be somewhat like, if you will not design your experiments in a better way, it would be somewhat like throwing anything which is coming to your hand and throwing it onto any blank wall, and anything that sticks to that wall is considered to be the best result for you. But in real life, we cannot get the results like that. So this doesn't come under the experimental designing. So when we perform the experiments under the controlled set of conditions, we perform it in a randomized manner. And you can see from this picture, these yellow points are actually the experiments. But sometimes when you do these kind of randomization, we miss certain, the points like these square circles, which might contain the optimum result. So the experimental designing should be in such a way that we must cover all the aspects which could be of importance to get the desired result out of it. Another story that I want to quote over here, for example, I think you must have heard about it, about the story of 6 blind people who were actually asked to give their perception about the elephant, and they were placed at different places near the elephant. So the one who was actually one who touched the tail of the elephant said that it is actually like a rope. The one who touched the body, he said like it is like the wall. The one who touched the ear said that the elephant is like a fan. The one who touched its trunk said that it is like a snake. The one who touched its actually the main tooth out, she said that the elephant is like a spade. So depending on the kind of location where you actually are working, you are going to perceive the results out of that. So similar is the case with these blind people also, because they are blind in the sense they have not worked on it, and they just went to one area, and just on the basis of the touching to that area, they just made up their mind that elephant is like this. But it is not so. The design space in this case was the entire elephant. So they must have touched the entire elephant, and on the basis of that, they must have come to some conclusion relating to the kind the elephant actually is. So here comes the concept of this knowledge space, design space, control space. Now so knowledge space comes when we do proper literature survey. Then design space, it is almost a little bit near to the results, but not the exact result. And then comes your control space, where we actually get the optimum result, the best results out of our treatment and the combination. So there are different approaches to experimentation. First is the trial and error method, which we had been using since years, but now with the technological advancements, now this has been completely removed, and now we have come to the part of the designing of experiments. So earlier we used to do, during our college time, we used to do the one factor at a time approach. This was also there. So what is there in the trial and error? I need not to explain it. You can compare it with a kid playing with a block, with a toy block, and he keeps on trying. He gives a trial to it, and every time, might be first time he'll fail, the second time, the third time, but with as he gets to prepare for it, he might get the better result. But this is again a trial and error kind, the way he built the block. So this is actually the trial and error example. Another is one factor at a time. So this is the kind of approach in which we keep all the factors at constant, and we just vary the single factor. So as you can see in this picture, there are three blocks which are shown over here. The factor one, and the score is the result that you want out of it. So you can see as the factor one increases, the score also increases. So in this case, again, what we have done in this, all the other the factors have been kept constant except the factor one. The another one is a factor two, where you can easily see from this graph that as the factor two increases, the score actually in this case decreases. So that means it is inversely related to the factor 2. The third one is the one where there has been no major change in the the score with the change in the level of, or in the concentration of factor 3. So again, in this case, although we get the results, but it is very time consuming. We have to do number of experiments at a time. It's quite expensive. And in this case, the one most important thing that we avoid is actually the interaction between the factors that might be the deciding factor for the final result that we want to obtain out of it. So again, this is an obsolete technique now. So when we want to go for experimentation, the first foremost, this is actually the general chart that we must keep in mind. The first is the question. Then on the basis of the question, we draw a hypothesis. Then we try to test this hypothesis by means of prediction. We use certain variables, whether they are the processing variables or the formulation variables. Then we go for the control to block certain variables which could actually affect our main formulation. Then we go for the selection of materials, and then the final planning. So the first and foremost thing in this case is the problem, the recognition of the problem. What is the best question for an experiment? And in this case, the thing is that it should be testable with the materials at hand. The second, we must, on the basis of this, we draw a hypothesis to guide our investigations. So in this case, mainly we rely on if and then kind of a statement, right? That is, if this is the case, then what could be the probable answer for it? So this if and then statement must be drawn on the basis of hypothesis. So I'll quote one example here that whenever the car, if for example we are going to for some the travel, then long traveling, and our car stops. So what could be the possible reasons that we could think of it? Either there's no gasoline, there is no petrol in it. So then we go for checking the gas valve or the petrol tank. Then the battery is dead. That is how we can check it. Then we go look for actually we try the lights to see if they work. Then third is there is an ignition wire, it is loose. So then we look for whether we keep on jiggling the wires, that if there's some issue, then it can be corrected by means of touching them or shifting to some other like that. It is for actually a new person. So on the basis of this, we can draw the steps in the scientific method. So first, you must ask a question that why doesn't the car start? Second, we formulate a hypothesis here that maybe the battery is
There is a dear participant. There is an internet issue at the speaker's end. So please be for a moment. She'll come back.
Visible to everyone? Dr. Poonam?
Yes, ma'am. Please continue, madam. It's visible. Hello? Hello? Ma'am, am I audible? Hello? ఆవిడ కరెంట్ పోయినట్టుగా ఉంది సార్. జాయిన్ అయ్యారు, మళ్ళీ పోయింది. అదే అయ్యి ఉంటుంది మరి. ఇంటర్నెట్ వచ్చారు. ఆవిడ మైక్ యాక్సెస్ ఇస్తే అవుతుంది.
Hello?
Yes, ma'am.
Yeah, I'm so sorry.
Madam, please continue, madam. Your slide is visible.
Okay. So we were discussing about the kind of experimenters, the kind of approaches for experimentation.
Madam, please switch on your video, madam.
So this is how we actually draw the hypothesis, and then we try to prove it by means of different experiments. So this is now we are coming more to the scientific side, where we actually formulate a hypothesis, we design the experiments to test this hypothesis, and on the basis of that hypothesis we conduct the experiments, and then on the basis of the results obtained we compare the results. So if we get the positive results or the negative results, we draw certain conclusions out of it. So either we go for refining our hypothesis and perform further experiments, or we go for the final report finding, if we are sure that whatever we have obtained in the form of results is the final one, and then we accept the hypothesis, and then here comes the actually the law then comes into being. So when we design any experiment, we must the first thing that should be there is the question, and then the hypothesis, and then third, which is most important thing, is the variables that we can actually vary. So variables are what? They are basically the things that are bound to change or that we can change. So in experimentations, we have two kinds of variables, the independent variable and the dependent variable. When we say independent variable, it means these are actually the manipulated variable. That is, we can change these variables. Then, or they are purposely changed. When we talk of dependent variable, they are actually the response variables, or based on the change in the value of the independent variables, we get the changed value of the dependent variables. So in a way, they are the responding variables. So dependent variables are what we actually want to measure in actual, the response, and independent variables are the one that which are in our hand and which we need to change or which we can manipulate. So when we say there are different classes of variables, first is the categorical, another one is the continuous variable. Categorical means it has got the the discrete answer, the end point is there, that is either yes or no. It could be like the gender, male or female, or it could be like small, medium, or large. When we say continuous variables, means it can have different values like height, weight, age, the distance, the speed, the power, the concentration, and so on. So this is in general about the variables. Then comes the constants or the controlled variables in an experiment. So these are actually the factors that are always kept as constant and they are never changed. Okay, so because it is very important to, when we want to interpret any data, there must be certain controls to avoid the biases. Then coming to the materials and procedures, this actually involves what all materials we actually intend to use for our experiments and how we are going to use it. So we must be sure to include certain points at this juncture. The first is listing of the variables. Second, repeated trials. And third, the drawing of the apparatus or the equipments that we want to use in these experiments. So there are certain terminologies before moving to the final one. There are certain terms that we must be aware of. The first is the controlled experiment. That is, as the name suggests itself, it's a study where the treatments are imposed on the experimental units. So in order to get the final response. Then comes the factor. Factor, I've already said that these are the variables that can actually affect the response. So these could be processing variable or these could be formulation variable. Third is the treatment. Treatment is what? It is actually the combination of factors, the combination of A with B, A with C, A with D, like so on. Then comes the levels. Levels are actually the values of factors. For example, if I'm selecting one variable as a temperature, so the value of that factor temperature, that includes the level, like if it is 10 degrees C or 20 degrees C, like that. Then comes the effect. So this is actually, this indicates that how a main factor or the interaction between the factors influences our main response. This is crucial in the case of design of experiments, which we otherwise cannot, detect. The interaction effect we cannot detect by means of the other experimental approaches. Then comes the response variables. Then another very important is the design space. This must be recognized well in advance. As I've told you, when we want to go on for making a building, that design space, the area where we want to build our building or construct our building, this is very important. So this actually includes a range of values over which the factors are to be varied. Then second, another term is the design points. These are again the values of the factors. So one design point generally means the one treatment, the one combination of factor. So depending on for our convenience, we normally code them as, in the form of -1, +1 and 0. So if any factor has got two levels, so for the lower value, we place the code as -1. For the higher value, we place the code as +1. Then another term which is actually very important is the response surface. So this basically represents the mean response at any given level of the factors in the entire design space. And this is very important for selecting the optimized value out of our experiments. And there are certain other terminologies which are very crucial when we want to go for the experimentations: interaction, replication, blocking, and randomization. These things they must be performed when we want to design any experiment. Another term which is very crucial at this point is the interactions. So when we talk of these design of experimentation techniques, they are so well versed that we can get number of interaction results in the form of interaction plots. So in general, the more slopey the line, it means the more is the interaction effect. If it is a parallel line, that means there is no interaction between the factors. So as you can see in this, you can see it's a graph of factor A at different values of factor B. And this indicates the output. Any output, it could be any response that we want out of it. So you can see these are it's little slopey, it's not parallel. That means some kind of interaction is definitely there in this kind of combination or treatment. Now look at this. This is the interaction 2. So again, if we compare the interaction 1 with the 2, you can easily make this out that in this, it has got more steeper slope. So this indicates that the interaction is even more intense in case of the second treatment. Then this is the third interaction. You can see over here where the line are intersecting each other. So this indicates that it's a clear indication that they are interacting with each other. On the contrary, if this would have been a straight line, then this would have indicated that there is no interaction between the factors. The next is the randomization, which is very important. We must, in order to avoid any kind of biases, the prejudices, we must randomize our experiments. So because if there would be any such kind of the bias would be there, then our results are also going to be affected out of it. So randomization can be there in the run order. It can be there in the the selection of the material, the selection of the subjects, the experimental trials. So this must be done, which is very crucial for experimentation. The next is the blocking. Blocking is again a very important technique, because this is used to increase the precision of any experiment. And normally there are certain cases where we cannot actually totally randomize the experimental runs. So might be because the experiment is very costly, or it takes a longer time. So in that case, we perform the blocking, where we it means to run all the combinations at one level before running all the treatment combinations at the next level. So but what we can do in this case, that experimental runs within the blocks can be randomized. So in this way we can have the the results, the better results, but for especially for those combinations which are very costly and which are very time taking. Then comes the replication. So this is again very important. When we want to go for multiple experimental runs, we must do the replication. And we can also use it for studying the test effects for statistical significance. And sometimes it happens that repetition of a basic experiment, it is simply the there is a difference between the replication and the repetition, right? So when we go for a repetition of a basic experiment without changing any factor, it allows us to estimate the any kind of error which might be there in our experiment. And this error is known as the noise, which is difficult to avoid. So this we can actually do by means of this we can avoid by means of replication of our experiments. Now then comes we have discussed that designing of experiment is so crucial. But why this is so crucial? First and foremost important thing is that it reduces the time to design, to develop the new products and the processes. It improves the reliability and performance of the product. It helps us to achieve the product and the process robustness. We can think of getting the, we can be sure of getting the similar results every time whenever we go on for using the similar combinations or the treatments. Then, because there are the minimum number of runs in this, so ultimately the cost is being reduced. Then we have the maximum yield out of it. So design of experiment is very important. So the goals that we want out of experimental design is that we want to avoid the experimental artifacts, which is really a big problem when we talk of the research and the scientific researches. It eliminates the biases. So we can have actually simultaneous control groups, the randomization, the blinding. It reduces the sampling error that can be reduced by means of replication and blocking. So this is the general model of any process or a system. We have the input, which we put into any process to get the final output. So there are certain factors which we can control, and there are certain factors which we cannot control. So the controllable factors are actually the independent variables which we can control, but the uncontrolled, which are we are aware that it could affect our final output, but we cannot actually avoid it. So these are actually the noises which can be minimized but cannot be completely eliminated. So this design of experiment is also known as the designed experiments or experimental design. So when we talk of the types of experimental design, the first type is actually the screening design. This is the preliminary screening rather, where we select the factors which could be significant in any experimental setup. Then comes the second, which is the response surface design, where after the screening has been done, we select these factors, and then at this stage we select the best possible combination of these factors to get the optimal results, or by selecting these significant factors. So this is the entire flow chart, like where we do the initial screening, where we look for the known and the unknown factors. Then on the basis of this, we get certain results. We study about the factor effects and interaction. If there is no interaction, then we simply go for the verification of our work. And if it is yes, if we get the positive result, then it's the time to celebrate that we have got the final result. If no, then we have to keep it again for the backup, that this is the negative effect of this particular experimentation. If it is yes, then we go for the risk. If the factor effects or interactions are there, then we go for the response surface methodology, where we select the optimum out of it, and then we verify it by means of different methodologies under this DOE, and then we get the final result out of it. So there are various screening and optimization techniques. It's a general overview that placket Berman is there, fractional factorial design is there, the two-level full factorial design, which is the immensely used technique for it. Then we have the optimization techniques like Box-Benken, central composite, the three-level factorial, and so on. So when we talk about the screening in case of optimization, we look for actually the factors that could be the major ones or the significant ones that could affect our the major formulation outcome. The second step in this is the improvement, where we try to reach towards the optimum. And the third is the determination of this optimum by means of the response surface methodology techniques like central composite design or Box-Benken, like that, where we look for actually the eigenvalues. So the setup is somewhat like this. You can see over here the current settings, where we go for the different combination of factors. We try to improve it to reach to a certain point, that what could be the the best possible combinations, what could be the significant factors. So this is up to the screening technique. Then after the screening point, the next is actually the optimization, where on the basis of these significant factors, we select the best combination of these factors at the optimum point. So again, in statistical designing, we use the regression modeling. Regression is what? It is simply to make anything linear. That is to get a direct relationship between any different combination of the factors. So you can see over here, the first order model is there. Nothing, it's very difficult to get the linear kind of results because because of interactions, the effect between the different combination of factors. So we try to linearize it to the point where up to which it is possible. So we rely on the first order or the second order model, and on the basis of that we get the such kind of regression equations. So this would be more understandable. See, if this is the optimum point is this red one, and we have tried and carried out the experiment in this way, where these black are actually the work that we are actually carrying out. So in this case it's a first order, but it is nowhere near to the optimum point. So again, this first order model fails over here. The second model, you can see these yellow points are our outcome, and we have tried to linearize it in the form that it must reach to this red ball, which is the optimum point. So if you compare it with the previous one, the first order model, the second order model is somewhat near to the optimum point. So we can go for selecting this second order model. So in a way, we can say that by means of these kind of modeling technique, we try to linearize our results in such a way that we must be more close to the optimum points. Another technique that we do in this is the center point approach, where we look for, after -1 and +1, we look for some center point that is a 0. So it actually gives a better variance estimate, and it allows us to test the curvature using a lack of fit test. So this is really very important when we go for the design of experiments. Normally experiments are not single layered, they are multi-layered. Okay, multi-layered in the sense that they are not like we will perform the experiment and we'll get the result. We have to go for an initial experiment, the preliminary screening. So in this, we check out the experimental equipments, we get the initial values for the quantities of interest. Sometimes we also rely on the literature survey for this. Then we perform, after this initial experimentation, we perform the main experiments, where we obtain the results that support the goal of our experiments. And then after the main experiment, then comes the confirmatory experiment, where we try to verify the results obtained out of the main experiments. So these are more focused, and this helps us to reach to the optimum. So you can see over here that the fractional factorial is for screening. Screening means selection of the key factors or the significant factors. Then we go to the full factorial, where we look for the characterization of the interactions. These are high resolution fractionals. Then third is the response surface methods, which is for optimization. So this entire process can be compared to this picture, where we start at the end of this, we want to reach to the tip of this mountain, and we start at the bottom of this mountain. And you can see when we move to it, we initially try to screen out the path, which is the fractional factorial. Then we move somewhere at the middle point, which is for the where we look for the interaction characterization of where we do the characterization of interactions. And finally, by optimization, by response surface methodology, we reach to the main top point of this peak. So you can see that this is the entire region of operability, that is a design space, which is the mountain. And as we move towards the peak, that becomes our region of interest. Then the short checklist before moving on to the design of experimentation, that we must clearly state the objective of our experiment. We must check the constraints or experiment. What could be, the constraints on the factor combinations or changes, or constraints on the size of experiments. We must make sure that the measurements that we are doing under constant external conditions. And then we must also include the center points to validate our model. So these are certain points that we must keep into consideration while moving on to the design of experiments. There are a number of softwares which are available. Minitab, Statis is there, Six Sigma is there, and they're so wonderful to work with. They make your life so easier when you want to go for statistical designing. I've been using the Statis software. So we must have these things in mind, that is the objective. We must identify the responses, what could be the factor effects, and how many runs does the budget allow to us, which is very important. So I have just quoted an example using the Design Expert version 11. Now the 13 is also available. But this example I've quoted with the Design Expert version 11. As you can see this window, when we actually open this up, you get the window like this. So this is on the trial version. This is not the completely purchased one. Most of the features are actually well available with the trial version also. And we have been working since, I think, last 16 years on the trial version. So when you open this up, you'll see it will show the 3 tabs. That is the design wizard, the new design, and the open design. Okay, so when you click on this design wizard, you will see that the number of different types of designs which are customized, which are actually there inbuilt in this software, and further some of them are customizable. You can customize them on the basis of your need. Then comes a new design. Anyone new design that you have inserted into it that you want to work with, that you can click on it. And last one is the open design option, where already if you have actually made some design pattern, the experimentation pattern you have made into it, you can simply open that already saved tab using this tab. So this kind of window opens up on the main screen. You can see over here the 2, 3, 4, 5 on this horizontal tab, they represent the factors, and those on the the vertical line, they represent the number of runs that we need to perform using these factors. And this is generally for the factorial, the full factorial and fractional factorial technique. So when we want to work on the 2 factors at 2 levels, then we need to perform the 4 runs. 2 factors at 3 levels, then we need to perform the 8 runs, and so on. It is like that. We need not to calculate it. The system calculates it for you. So this I've already discussed, that we must have the minimum run, the screening, the characterization, the optimization. Sometimes we also have the mixture designs and the split plot designs. So if you see the screening experiments, see the white colored and the yellow colored one, you can see over here. These yellow colored ones, these are for screening purpose. The initial screening when we want to go for selection of the principal factors. Then when we want to go for, the minimum run of any experiments, then we can go for this red colored options. Then if you want to go for the characterization of the main effects, characterization of the, the interactions, then you can actually click on these full factorial tabs, the white colored ones. Then if you want to go for the optimization, then we have some other settings which are available, like box Benton, central composite design, which is not mentioned over here, but it will be there on the vertical tab on the main screen. Then sometimes it happens that we have the mixture design also, where especially when we want to go for the chemical composition. So in that case, we select the mixture design, where we can use the combination of designs like screening plus optimization, like that. Sometimes we also have the split plot designs. Why this slide is automatically changing? So split plot designs are, they are used to screen as well as characterized. So based on this, you can easily see, but normally what do we do? The more the red colored ones, we normally don't perform them. As we move to these yellow and the green and the white one, they are the mostly performed experiments in the experimentation techniques. So then comes your
Madam, slides are not moving, madam. It's on 53 slide
I think
only.
there is some issue with the slide. It is
Okay.
changing on its own.
I'll move them, madam. You just tell me the slide number, telling, I'll just move them. Madam, the slides are not moving. You just tell me, madam. I'll just move the slide.
Dr. Purna. There's some problem with the, when I'm clicking the next slide, it is not moving. It's again returning to the previous slide, I suppose. So then comes...
Madam, please tell me which slide you are
Please
telling.
see
I
to
just
it.
move from my end. I'll just move from my end.
Again, it is returning to the previous slide. I want to go to slide number 55.
It's in slide number 55 only, madam.
56.
Okay.
Madam, am I audible to you?
Please, I'm not able to assess this. Please move to the slide number 55. What is happening?
Ma'am, please stop moving the slide. I'll just move from my end. Ma'am, am I audible to you? Hello? Ma'am, am I audible to you?
So we'll just simply move to one example that I've included over here. Dr. Purna, there's some issue. It's not moving further.
Ma'am, am I audible to you? This is Anita Raj Panigrahi.
See, we have number of options to analyze or diagnose our results out of these experiment. We have certain, the graph patterns which we can obtain out of them. We have the design patterns, the statistical data we can obtain in the fraction of seconds out of it. And these, we have certain transformational graph models which help us to analyze our data. So I just want to show you this with an example. So I've included one two-level factorial design with a 4 levels. Example I've taken from Douglas Montgomery's book, where there are the 2 levels for 4 factors we have selected. The major response that we want to select out of it is the filtration rate. Another desirable point that we want in this is that we want to reduce the amount of glutaraldehyde, which we all know that it is having the carcinogenic effect. So these are the 4 factors: the temperature, the pressure, concentration, and the stirring rate. So who is controlling it, ma'am? The slides are not stable. Why they are moving on their own? So these are the so this is an example that I wanted to show you how it looks like: the low level of these 4 factor values and the high level of these 4 factor values.
మీరు డయల్ చేసిన నంబర్ ప్రస్తుతం బిజీగా ఉంది లేదా ఈ సమయంలో అందుబాటులో లేదు. దయచేసి తర్వాత ప్రయత్నించండి. आपके द्वारा डायल किया गया नंबर अभी व्यस्त है या
So this is the general pattern that I've selected. I think there is some technical issue. It's not moving further. Because I just wanted to show all of you the how actually it works, like the entire window of Design Expert, the different combinations. This is how it looks like when we open this up. It's not moving further.
जिससे आप संपर्क करना चाहते हैं वह अभी स्विच ऑफ है. कृपया कुछ समय पश्चात प्रयास करें. The number you are calling.
Slide is not moving further, so we'll just move to the hello, ma'am.
Hello, ma'am. I'm Harini, ma'am. Ma'am,
Huh.
due to network issue here, it is disconnected, ma'am. Can you reshare your PPT once again, ma'am?
Oh, so
That is where the slides are not moving. And
okay,
this time, if still the slides are not moving, from here we will move the slides, ma'am.
okay,
You tell the slide number.
okay. So I'll just share it again, no?
Yes, ma'am. One second, please share.
Mhm.
मेरी स्लो ना कंगा तुम म्यूट करो Madam, am I audible to you? Hello? Hello? Madam, please unmute yourself.
Harni ma'am, can I start now? Dr. Harini. I hope that it's visible to everyone. Should I start, Dr. Harini?
Madam, am I audible to you, madam?
Yes, you are very much audible.
Hello?
Hanji, you are audible, ma'am. So can I start with the presentation now?
Hello?
Hello? Hello?
Hello? Madam?
Yes, yes. Hello? Hello?
Hello, ma'am.
Yeah, I can hear you. Hello? But yes, they're changing. So should I like start with the presentation now? Okay, so how it actually this is the level of an example that I wanted to show you all, that these are the factors, the 4 factors selected at 2 different levels. The level one, that is a low level, represented by minus sign, high level represented by plus sign. In temperature, it is 24-35 range, pressure 10 to 15, concentration 2 to 4, and stirring rate 15 to 30. Now in this,
Madam, please continue your presentation. I will just move the slides, madam, if there is any internet issue.
No, I've already started. Can you hear me? Okay, so the goal in this case, in this experiment, is to maximize the filtration rate, and one of the desirable factor in this is to reduce the concentration of formaldehyde, which is the factor C. So when we click on the, when we click on the window, we get the window somewhat like this. Then on the basis of this, we select the regular 2-level factorial. Again, this kind of screen would be visible to you. Because we have selected 4 factors at 2 levels, so the kind of experiment that we'll have is a 2 to the power 4, which is a full factorial. You can see the black one, which is the selected one. So in this, we will have the total 16 runs, means we need to perform the 16 experiments out of it. Then comes time when we need to input our data. So you'll get the window somewhat like this. In the drop down list, you will select the number of factors, that is 4. The rest of the data you can fill. Then response, because we are just working on the single response, which is the filtration rate, and the unit will enter over here. Then we'll put the range that difficult to detect the data signal is from 10 to 5, and the signal to noise ratio will come out to be 2 in this case. So this will be the design power result that we will have, and it must be more than 80% or greater in order to get the better results, in order to get the better orientation towards the effects. Then next is actually this is the kind of the entire chart that will be in our hand. This is a initial notes, a notepad, and here you can see the factor 1, different levels, factor 2. We have the random combination of these 4 factors with the responses entered into this. Again, the standard run order is also random in this. Then after this, we can either actually change them in the form of you can, as you see in the previous slide, this is in the actual values. Here we have changed it to coded value. So this depends on you actually, whether you want to show the combinations or not. So you can keep them in a coded way or in the actual way from this drop down menu of display options. Within this, the process parameters either as actual or coded. After this, then we go on for the pre-analysis of effects through data sorts and some scatter plots. So these scatter plots you can see over here. We can select the color. In this we have included the color on the basis of the run pattern. Then we have first on the x-axis we have the temperature with respect to the filtration rate. In x-axis, in the another one, it is the pressure with respect to the filtration rate. So you can see the more is the color intensity towards the the red one, it is having the more intense the interaction effect, and the lesser one is the towards the blue side. So you can see over here also how it actually looks like at the different combination levels. Then if we want to transform our results, then we can go for transformation also, where we can actually make it more linearized using the different transformations which are there in this menu, the window. You can see over here, if the ratio of maximum value to that of the minimum value, it is actually, if it is not greater than 10, then we need not to go for the transformation. But if it is more than 10, then there is a need to go for the transformations. So here, because the value is less than 10, so we need not to go for the transformations. This is the half normal plot, and in this we can actually select the different values which we want to include. Like you can see, some of the values are scattered, so we need not to, which is quite far up from the significant terms, and those falling on this average line, which is represented by the red line, we must select these points. So you can see over here, these ones are the deselected ones, which we are not going to include in our results. So we get the output in this form, where all this the points falling in on this the middle line, which is the average line, they are actually selected, the rest are not selected. And then it actually helps us to limit the lines. The color coding helps us to recognize which factors. We can also study the interactivity in this. So we can also have a Pareto chart by this means. This helps us to study about the T effect. Then we get actually the ANOVA, or at the diagnosis menu only, we will get the ANOVA and the statistical analysis details in this way, where you can get the information about the sum of squares of individual factors, as well as if any kind of interaction is there, which you have selected as the significant one, that you can select over here, like A and C has been found to be significant. So you can see over here, the A and D interaction has been found to be significant over here. So the F value, fiducial limit, also you can the data that you can obtain out here, and the P value also. So then and you need not to actually work on it, because it also gives its analysis also. At the end, you can see it is written that the model F value of 56.74 implies that the model is significant. So this software does it for you in all way. Then Then the next point is to validate the model. So this we do in terms of the normal person probability, and the points falling on this middle average line, the red line, they are considered to be the major ones. Here you can see the plot between the residuals and the predicted values. Again, in this, the minimum is the percentage bias or the residual, the much better is your model. So you can see the how the for this kind of residual and the run effect, the comparison is there. You can see the Box-Cox plot for power transformation also, and this is shown with the color coding also. As you can see, this blue line over here, it shows the current transformation. And in this, normally what is there, if the value, please be at slide 80. Yes, the optimum value lies between these two red lines. If you can see, there are two red lines. And if you're this blue line, which is actually the major current transformation, if it falls between these two red lines, that means your result is actually having the 95% confidence interval. It falls between the 95% confidence interval, which is actually the optimum result. So no response transformation is required at this point. So you can validate your result by using this kind of Box-Cox plot also. So again, when we want to study about the diagnostic case statistics, you get the results in this form, where you can get the value, your actual value, the predicted value tab, the residual, the leverages. So on the basis of these residual, you can even come to the point that if there is not much of a bias between the actual and the predicted value, this indicates that your model is actually the highly confident one. It is more than 95% confidence level. Then this can also give the results about the, it can help us to examine the main effects or any kind of interactions that are there. You can see over here between the temperature. At this, this one, the right side tab, you can see, you can select the different factor combinations if you want to study about their main effects and the kind of interactions. This is for stirring rate with the different combinations. You can see over there. I suppose that my cursor, if it is visible to you, it is showing the term AD, the interaction between AD here in this slide. AD, we can study at a time the effect of temperature, effect of pressure, effect of concentration, the stirring rate on the major outcome or the response that we want out of it. So in the similar way, other kinds of interactions are also there. Then we have a cube plot also. This is the best technique to analyze your result. So you see, actually, what was our main motto when we wanted to perform this experiment was that we wanted to use the minimum amount of the formaldehyde, which was the C. Okay, and we wanted to have the maximum filtration rate. So as you can see, these different vertices of actually these cube, they represent the different treatments, and the maximum value has been obtained with the this point. If my cursor is visible, it is 100.625. So this is at the maximum level of A, which is 35, the maximum level of actually the D, which is 44. And you see, the major beauty of this thing is that it is at the minimum level of C, so which was actually the desired thing for us. And here you can see, by selecting this also, we can go for the selection of our results. Then we have the contour and the 3D plots of interaction also you can get from it. These are the 3D response graphs. They are in the saddle form, the ridge form, there are different kinds of patterns of these 3D plots. Then further, the last step is actually the post analysis, is the confirmation phase, where actually we try to confirm our results, and system and the software gives you the best result. As you can see at the confirmation stage, it says that they're two-sided confidence with a 95% level, and the result obtained has been equal to 80.2078, which is the optimum one. The final confirmation, it gives up with the predicted mean of 70.0625. The median is same. Then the final value comes out to be the 78, which is with the combination of temperature, pressure, concentration, stirring rate at this much level. That is 29.5, 12.5, 3, 22.5. So this is actually the optimum values of these four factors to get the maximum filtration rate of 78. So on the basis of this, then we prepare the final report with the entire validation, the entire confirmation. So I think with this design of expert software, although I have just explained about a smaller part of design of experiment, otherwise there are number, the options which are there in it. I had just explained you the full factorial design using the 4 factors at 2 levels. But there are a number of other, the patterns and the approaches and designs are there inbuilt in this software. So by this, we can have the maximum information with minimum number of runs and the high reproducibility. And I think with this, the elephant in the way, our final result that we want out of our experiment, it will be rightly perceived if the experiment is properly designed. So with this, I know that there were some certain technical glitches, issues in between, but with this, now I come to the end of my presentation. Last but not the least, I would like to say that wisdom is not there in the amount of knowledge that we have, but it is actually in the degree of its application. I really agree to the words of Swami Vivekanand ji that we must, whatever we have learned, we must learn to implement it in our day-to-day life, or for actually, if we can use it, even a fraction of it for the betterment of our society, then it could be a real wonder. So thank you so much for patient hearing. I know there were so many glitches, but with this, I come to the end of my presentation. Thank you so much.
Thank you, madam. That was indeed a very informative session, and we are also sorry and apologize for these technical issues which appeared in the middle of the session. So now I invite our principal, sir, Dr. Jagdish Panda, into the session.
Right from the morning,
Yes, ma'am, please.
I'm saying right from the morning, so many issues were there, but okay.
Amma, unmute karo kata.
Yeah, actually, we have been facing with some troubles. We have 3 internet connections, different connections. But even then, because of the rainy, because and all these things, we are immediately resorting. But anyhow, for sorry for our inconvenience, and from your side also, there certain loss of internet was there, I think. Okay.
Yeah, it's raining here also, sir. It's raining
Yeah.
everywhere.
Anyhow, so we have done a wonderful job. You have done a great job, and I feel that this is not enough with this presentation, madam. One workshop should be there. So
Very true. Because, it is very difficult to include all the points. I
yes,
wanted
madam.
to include
Madam.
it.
Actually, we have actually applied box benching method and other methods in our method development analysis. It is mostly we do practice, but but when it comes to the overall this one, but is
It's very difficult.
no one is understand what is what. Actually, suppose if we teach, suppose a teacher is who's very versatile with particular design, okay, composite design or box Duncan design or some design, they'll apply and apply and apply and go on. But unless you like a senior fellow will come and overall benefit of each design, unless somebody tell, no one will they never come out from particular that's their what they knew that one. And the latest softwares also. And the era has come that, as you said, that whatever the knowledge we have, that should be, practically that should we have to implement. So for that, definitely, madam, I feel definitely we will arrange one workshop, madam. Kindly, you should take care of that one, and we do all the needful. And whatever the resource persons you tell also, we will accept, and whatever the expenditure. But I believe that this reason at least, okay, the practical workshop, we are very always used to conduct a good
Yes, that
workshop.
would be more helpful.
And this time we are coming with the workshop for this only. Design of
Okay.
experiments and applications in different this one we do, madam. And thank you, madam. Thank you very much. And definitely
Thank you.
anything, any question?
Sir,
Madam, this is the certificate we are going to send you, madam. Okay.
so
Thank
there
you,
are some
sir. Thank you
questions
so
in the
much.
session, sir. Before that, this is the e-certificate. We would request you to present to Madam Dr. Manjeet Singh. E-certificate. Present.
Any questions?
Yes, sir. So At very first, there were many messages which applaud Madam's session today. So that was a very informative session, excellent session. So one of the question is there is any software to interpret the counter plots, Madam?
See, actually, when we work on these design experts, also, you can actually interpret by looking at those counter plots also. They have their inbuilt, that I told you, that we need not to analyze it. They give you the result also at the bottom. You get the colored section where they explain the results also. Although they don't have to do it, software will do it. But as you click on the points where you want to you want the result out of that, it'll like as you click on that point on the contour plot, it'll give you the entire information relating to that point. But if you want the information about the interpretation, then at that case you need to learn about it.
Thank you, Madam.
Any other questions?
Thank you so much. So that's
No,
it.
sir. Yes, ma'am. And since this is a vast area or ocean of knowledge, so many of us have to know first what is what, and then we can ask you a question. So hope if anyone is having any doubt, they'll put forward in the WhatsApp group, and we'll share with you, so that they will be
Email me.
correct.
You can mail me. No issue.
Okay.
Okay. So can I leave now?
Uh, just wait, madam.
So
Okay,
now
sir.
would like
Namaskar.
to propose
Just wait.
vote of thanks to today's session. So indeed, the session was very elaborative. Indeed, the session was today elaborative, and Madam has discussed regarding a vast areas in the research methodology, like randomization, blocking, and replication techniques to minimize the errors in research methodology, and the various types of experimental designs, which includes screening and response surface methods. And Madam has also highlighted the importance of screening and optimization techniques in planning of experiments, and insight in the box Bentham design, composite design, and three-level factorial essays, and a touch of the regression models, which are very much important, and they are very resourceful in the design of experiments or in the formulations especially, and the glimpse of the softwares which we require uh, in repetition of experiments like design expert, stat ease, and Six Sigma concepts, and also the factorial designs which we require in our optimization studies. And these were the highlights of the today's session, and which we further have to know what is what. And since it is an ocean of knowledge, which we had a small glimpse from Madam Dr. Manju Singh, so we hope further cooperation with you, so that you enlighten all the budding researchers like us in having a small experience from you, ma'am. Thank you for a wonderful session today,
Thank you
and
so much. It was
thank you,
wonderful interacting with you. Thank you.
thank you, madam, and thank you everyone for joining this session. And the afternoon session will start at 2 p.m. and the link will be shared soon. Thank you, everyone. And we
Thank you,
end the
madam.
live.
Have a
Yes,
good
sir.
day.
Thank you. Thank you.